One little part of a quick installation of a Haven airflow monitor. Right now I'm taking the airflow measurements, and if this zooms in correctly and is clear, you can see in position C, right now I have it in position E. Position C is perfect perpendicular with the airflow direction going through the air analyzer ports where there's a laser beam that looks for particles, for contaminants in the air. That was 648 CFM in that position. Then it had me go into position A, which if you see where position E is tilted like this, they had you tilted in the opposite. So there was an A here and an A here. You tilt it, you line up the little notches. In position A, it was 339 feet per minute. And now we're going to go to position E, which I am currently in, if you follow that up right now. And if you could see the little letters, see where the E and D and all the letters are right there? And there's a little notch on the end. Then you hit the start button, and you had to put in the size of your ducting. Oh, sounds like it's gonna fall out. And 673. Oh, 712. So they'll probably select that, and that's what it is. It has a little green check mark. And you go, well, why isn't one going straight have a higher CFM than one that is tilted a little bit and it's not going right through the, how can I say, the sensors? Oh, let me show you. Here, let's take a look up here. So here's where the old filter was, and it was one of those 3/4 inch or inch thick hog hair pieces of shit that they had up there. Filter killer. Motor, if it was the ECM, it was ECM motor killer. And it has a really narrow, thin grill on here that has really steep angle to it that also restricts your air. So this is a modification I did where I put duct sealant, and this is the floor for the upstairs apartment building. Here's the floor joist here, and all this is missing. These are gaps where air would be sucked in, because this is a negative area. Once you put the filter and grill in here, this is a negative area. This is going to get sealed off too, right here. This is going to get sealed off, and this is the only small area for feeding the air for this entire apartment building, to this furnace. And this is 9.5 inches by 13.5 inches is the dimension. You can see the airflow monitor right there, and you see the holes in it right there. You see those little holes? Let's see if I can zero in for you. Come on, zero. Right there. So inside there, there's air sensor temperature. There's humidity, temperature, and airflow sensor inside of there, and it tells you the airflow. And just because you're going straight, depending on the way the air passes down a duct, it doesn't always stay at highest velocity going straight. Different parts of duct have different velocities. As you go through a duct, the velocities change across its width. And depending on the turbulence, when it's coming up and over a corner, say like this, the air's coming up and it's going over a corner, instead of flowing straight, it tumbles and it's not straight. And see this little piece of wood right here? Because of this piece of wood and the air going over it, it's causing eddy currents and velocities. And at that point, being straight is not the highest airflow. Having it tilted because of the eddy velocities that are going in, see the eddy currents, the highest velocity and the most air over that little tiny hole where the temperature sensor is, humidity sensor, and the air quality particulate sensor is located, they wanted at a slightly tilted angle. That was their best airflow. And so the software figures that out for you. And so that's what I'm doing right now. Because of this massively undersized, huge restriction of airflow going through that tiny little hole right there, that 13.5 inches by 9.5 inches, that is feeding this large plenum. And because of the reduced airflow, you have a lower airflow going through this large plenum, and it was actually under when I did the same test. So I was going to do the test here. I did the test here. My highest one probably would have been right about here and barely would have made it, because this is where the motor is located right here, and the highest velocity is in the center, but coming off at a side because it hits the top of the motor right here would have been the highest. It was barely hitting over 80 was my highest number. And so these were not good locations in this scenario on this system, due to the fact of how restrictive that is up there. And so that turned out to be the best place to put it. And unfortunately I can't get it before the filters, because in this scenario they had two filter placements. They had a filter inside here that was impossible to get to, was never getting changed, and they had the filter right here I'm going to modify. So best scenario is you have this before your filter, but in this case it'll never be before the filter, it'll always be after the filter. I can't get it before the filter. This is a downflow furnace. So this furnace is going down below the apartment building, feeding out into the registers coming up into individual rooms. And this building, the upstairs apartments, it goes through the attic roof, and then they feed the hot air through grills that are located in the ceiling that don't throw the hot air down. It throws it across and up, keeping the hot air in the ceiling of the apartments up above, so they never get to feel hot air for a real long time. A horrible setup, whoever did this building. All right, so I'll see you guys from there. I will keep on going and catch you guys later. Haven for checking your air. You could look them up online. Let me see if I could give you, you could look up the number, name, find this stuff online. This is not for the do-it-yourselfer. And sorry I don't have all the information here, but good enough for government work. See you guys later.